For chapter 9, we're just going to cover briefly two important topics, vectors and matrices. They're important because you'll see them later in other math classes, but they're more important because there's a lot of real-world applications that we use them for. And the first one we're going to do is vectors. So a vector is just a quantity that has both a direction and magnitude. So you need to know a direction and a magnitude. If you don't have both, you don't have a vector. A vector is represented in the coordinate plane by an arrow drawn from one point to another. And if you look at FG, vector FG, you can see that it's just a ray. So a ray is basically a vector. But we read this as vector FG. Notice the little arrow up above. And you can say vector FG. And every vector, like a ray, has an initial point or a starting point. And in this case, that's F. But a vector also has a terminal point or an ending point. And in this case, that is G. Remember, a ray goes on forever in one direction. A vector has an ending point. And on the grid, we can break it up into the horizontal and vertical component. So this one has a horizontal component of 5 units to the right. We're moving 5 units to the right. And a vertical component of 3 units up. And notice how we would write that in the component form. So if we could write vector FG, and its component form is 5, 3. Pay close attention to the brackets, those arrow brackets that we use, as different than over here, the coordinate points that we use the parentheses. If you see parentheses, that shows you a point. If you see the arrow brackets, that means a vector. And remember, a vector is not a point, it's a movement. It's showing us how far we're moving right or left and how far we need to move up or down. So just pay close attention to the arrow brackets. Again, a vector has to have a magnitude and a direction. You can think of a lot of situations where you need both of those, right? Let's say we're trying to tell this girl how to hit the piñata. If you told her the right distance, that's great, but if she's not aiming the stick in the right direction, it's not going to help her much. Same thing if you told her the right direction towards the piñata, but not how far away it was, that's also not going to help her get there. So you need to give someone who you're trying to give directions to, the direction they need to head in and how far they need to head in that direction. One place we use this is in air traffic control. All of these lines are paths of airplanes. And you could think it's pretty easy to imagine how important it is for the air traffic controller to have all of these sorted out, right? You need to know where the plane is going and you need to know how far it has to go. If you only had one piece of information for each plane, it wouldn't be very helpful and it would be very difficult for you to keep those from crashing into each other. And just notice a lot of those lines cross, but remember they're stacking these planes in space, right? One could be at 1,000 feet elevation, another could be at 1,500 feet elevation, and that's how they're going to keep all these planes from running into one another. There are also other less obvious places where we use vectors. One is in graphic design. So raster means pixels. So if you take a picture, right, with a digital camera, it's just going to create pixels, and that's great because you can have really fine detail where each pixel can be its own little color, and so you can get like a perfectly detailed picture. However, as you can see here, when you try to blow up that S to the larger size, it gets pixelated because if your screen has 1,000,000 pixels and you try to blow it up, each of those pixels has to expand, and so you start to get that distortion. However, if you use a vector program, which all it does is says, it creates each line on the program is basically a little math equation saying like y equals 2x plus 1 or something like that. But as you expand that math equation can expand with it. And so you get this smooth transition. So if you want to do a gigantic billboard, for instance, where you're blowing up an image from your computer, you would want to use a vector program so that you didn't get that pixelation. So there's all sorts of areas where we use vectors. Those are just 2 of them, but they're everywhere. Now, how are we going to apply these on your problems, right? What are the basic ways we're going to apply vectors? First, let's name them and write it in the component form. So this is vector BC. I'm going to write it like that. Notice the arrow I have above the C because that's where it's going. And the B, there's no arrow above it. That's its starting point. It's component form. I need to move 1, 2, 3, 4, 5, 6, 7, 8, 9 units right. So that's 9 units right. So my x component or horizontal component is going to be 9 positive because it's to the right. And I need to go 2 units down. -2 is my vertical component. Notice the brackets. Okay, over here, even though t is on the left, notice t has the arrow. I am moving from s to t, so I need to write it as vector st. And horizontal component, I'm moving 1, 2, 3, 4, 5, 6, 7, 8 units left. So that is a -8 for the horizontal. I am not moving at all up or down, so my vertical component is 0. Okay? So how can we use this for translations? How can we show movement through using this vector? So we have this triangle ABC. I marked it down. And we want to translate it using this vector 5, -1. So just remember, this is not a point. A vector is showing us movement in space, showing us the direction and a magnitude through those two coordinates. So for each of my points, I need to move 5 units to the right and 1 unit down. So for B, I go 1, 2, 3, 4, 5 to the right, 1 down. And our image we call B prime. A, same thing, 1, 2, 3, 4, 5 over, 1 down. And I get A prime. C, 1, 2, 3, 4, 5, 1 down, and that is C prime. And two things. One, the vector movement for each one was 5 over, 1 down, right? That path is the same for each point. And I know my lines aren't perfect, but that's just my artistic skill. It has nothing to do with the math. We went 5 over, 1 down for each. And if you drew these images, notice these triangles are exactly the same, because translating an object doesn't change the figure. They're still congruent figures. Finally, a boat heads out from point A on one island toward point D on another, but it encounters a storm at B 12 miles east and 4 miles north of its starting point. The storm pushes the boat off course at point C as shown. So write the component form of AB. So from A to B over here, okay? So vector AB, its component form is, and I'm going to write it a little differently at first, and you'll see why. I'm going to say 12 minus 0 for the horizontal. I went to 12 from 0, and so that would be just 12. Same with the vertical component. I ended up at 4, started at 0, so that would be 4. So I moved 12 units to the right, 4 units up. Why didn't I just write that? Well, just to get in the habit of seeing that distance, that magnitude, because this was really easy because we started at 0. So to go from 0 to 12, obviously that's just 12. But what if we started at like 3 and you ended up at 12? Well, that would be 9. And how do we get that? 12 minus 3, our starting point is 9, right? So you can just get in the habit of writing the distance, the magnitude, as the difference between your end and starting point. Write the component form of vector BC. So BC, same thing. B to C, my horizontal movement, I ended up at 16 from 12. My vertical movement, I ended up at 2 from 4. So that would give me a horizontal movement of 4 to the right, which is exactly what you can see here. And 2 minus 4 is -2. So my vertical movement is down 2, which is exactly what you can see there. Okay? C. Write the component form of the vector that describes the straight line path from the boat's current position, C, to its intended destination, D. So CD, right? All we need to do is go from here to here and just break that up into its components. So I want to get 218 from 16, that's my horizontal movement. And I want to get 25 from 2, that's my vertical movement. And that's just 2 up and 3 to the right, and that would be my component form for vector CD.